Hello, it's Eric here, and I'm really excited about this series of videos on Russell's paradox. And because I'm a big fan of Bertrand Russell, and Bertrand Russell is one of those rebel rousers or underdogs. And once in a while, a rebel rouser or an underdog will come along and shake up the entire foundation of the establishment. And Bertrand Russell is one of those, rebel rousers. And yeah, so I really love his work, and so I'm really eager to dive into his material. But before I start, I want to mention again that I record all my videos on a smartphone, yeah, and I'm aware that the sound quality is not that good, yeah, and so I'm looking for some higher quality, more sensitive mics, to do the recording. But I want to be true to the original intention, because I want to just record everything on the mobile phone, on the smartphone, and then upload to YouTube immediately to get the message across. Yeah, I don't want too much fuss, and but there is room for improvement. But anyway, so let's get back to Russell's paradox, and then yeah, so last time we already started this Russell's paradox, and then we said that if you accept the validity of the Russell's paradox, then the whole of the establishment of the foundation of mathematics is going to fall apart. Yeah, and then of course the mathematicians are not going to allow that to happen. And then so they absolutely scramble to find solution to fix up this Russell's paradox problem. Yeah. Now remember, this Russell's paradox was discovered at the turn of the 20th century, and then so the mathematicians immediately went to work to find solutions to solve this paradox. And then one of the most popular solutions is, of course, the axiom of choice, yeah. And then this solution, has been widely accepted, even up to today, and so this axiom of choice has been in use for more than 100 years, and it forms the basis of everything that we know about logic, the first order logic, second order logic, and things like that, and but we're not going to dive too deep into the deep waters of logic, axiom of choice. I mean, you can probably do a whole doctoral thesis on this topic, yeah. But I just want to pique your interest in this topic, so that if you want to do further research, it's up to you, yeah. But I just want to pique everybody's interest, in this kind of a very interesting logical phenomenon, yeah. And then so yeah, so Russell's paradox is a big problem, so they come up with the axiom of choice. One of the most popular solution to fix this problem. It's a little bit like when you have a software program, and then sometimes you have a security loopholes in the software program, and then once in a while the software company will send out a patch, yeah. So you have to patch up the security loophole in your software program, yeah. So it seems to me that the axiom of choice is like a patch, to patch up the security loophole in this case it's in the foundation of mathematics, yeah. And so let me briefly describe to you what the axiom of choice is, and I'm going to give you an example now, and then in the next video I'm going to give you a counter example where the axiom of choice actually doesn't work, But so here, let me give you the probably the most popular example of the axiom of choice. Okay, so axiom of choice, like I said, is like a patch on a security loophole, yeah. But sometimes you don't need this patch, you don't need this axiom of choice solution. Now let me tell you what the problem is. So the problem is like this. Let's say, for example, I have many sets, yeah. And A1 is a set, A2 is a set, A3 is a set, and many sets, yeah. And each set is basically a set of natural numbers, Like for example, A1 is a set of say for example 2, 3, 4, and then A2 is a set of the natural numbers of 3, 4, 5, and then A3 is 4, 5, 6, etc., yeah. And then I can always come up with what they call a choice function, yeah, a choice function, and a choice function is to allow me to choose a specific element in each set, yeah, and then I put all those specifically chosen elements together to form a separate set, Like for example, in this case, I make up a choice function of finding lowest, the smallest number in the set of natural numbers. Like for example, in A1, like I said before, it's a set of the natural numbers of 2, 3, 4, 5. Yeah. So the smallest number in this case is 2. Yeah. And then A2 is the set of say 3, 4, 5, 6, etc., etc. So the smallest number is 3. Yeah. And then for A3, the numbers are 4, 5, 6, 7, 8, dot, 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 up to infinity. Yeah. So the smallest number is of course 4. Yeah. So therefore, my choice function in this case is to take the smallest number in each natural number set. Yeah. So therefore, in A1 I will take 2, in A2 I take 3, in A3 I take 4. So then I put these smallest numbers. Yeah, I put those smallest numbers together. That means I put the 2 and 3 and 4 and 5 together to form a set. Yeah. And then this set, is possible. It's possible to construct a set of smallest numbers in each of these natural number sets. And then, but the problem is that sometimes it is not possible to, to come up with a choice function to allow me to form a set of all the specific numbers in each set. And then in the next video, I'm going to give you some examples why sometimes it doesn't work. Yeah, that means the choice function doesn't always exist. But in this case, it exists because if you give me a set of natural numbers like 2, 3, 4, 5, I can always find the smallest number. In this case, it's 2. Yeah. But sometimes, if you're not dealing with the natural numbers, for example, dealing with the real numbers, then you're in big trouble. That choice function doesn't exist. If the choice function doesn't exist, that means I cannot construct a separate set of specifically chosen elements from these individual sets. Yeah. If you cannot do that, then you have to invoke what they call the axiom of choice. Yeah. That means basically you have to use a patcher to patch up the security loophole in a software program. And so in the next video, I'm going to give you some counter examples of why this choice function doesn't exist, and so therefore you have to invoke the axiom of choice. Yeah. All right. I'll see you in the next video. Bye.